Hi, I'm Etim Redon Tanvir. This is my combined Sprint 2 and Sprint 3 review. Starting with Sprint 2, where I had to prove the engine matches the published research and make experiments configurable. Goal and scope. The goal had two hubs: reproduce the papered numbers and make experiment configuration rather than the code. In scope, replicate table 6, 30 runs average per group, also a comparison table and the three scenario levers. A scenario guide also had to mention and also release it on GitHub. The definition of done was met here. This is my benchmark, Table 6 from Green and Colleagues 2024. Its full name matters. Type exposure at 365 days, cumulative. 3 words to unpack. Type means unique words. If a child hears dog 50 times, that 50 tokens but just one type. Exposure means words the child has met, not learned, simply encountered. And the cumulative at day 365 means it's the running total across the whole simulated year, read on the last day. My target is the plus one book column, child directed speech column, one book a day. Welfare about 28,000 types, working class about 37,000, professional about 47,000. Methods: how I measure the same thing, 30 runs per group, because one run is random sample, one control classroom, so differences come only from the home. Full 365 days years, matching the paper's measurement point, and two scripts automate the runs and the averaging. Here's that engine for real in VS Code. One Gradle command with a scenario file, the multi-agent system boots, parses the config, creates the children and parents, and simulate day by day until the result CSV is written. Powerful but terminal only. Remember that for Sprint 3. Results. My cumulative type exposure at day 365 against the papers. The social gradient is reproduced, welfare lowest, professional highest, and working class matches within 1%. The two extremes are off by about 18% in opposite direction. That has identified cause. The proper samples whole transcripts, preserving natural word structure. My tool samples individual utterances from a shared pool. That inflates type variety for the smallest word budget and saturates the largest, pulling both ends toward the middle. The fix is whole transcript sampling, a sampling change, not a redesign. The middle group matching within 1% shows the engine is sound. The second half of the sprint, three independent levers in one scenario file: the child profile, the parent profile, and home profile. The learning rule never changes, only parameters do. Scenario demonstrated. Three examples: an inattentive child taking in half the words learns fewer than an attentive peer. An ESL household draws from a narrower pool. So type variety at home drops. More books at home means more hard words. Each is parameter change, no code edits. Release 1. All of it come together as release 1, the validated simulation, 30 run averages, the comparison table, the three levers, and the scenario guide. That's already delivered to GitHub. Which sets up Sprint 3, making this usable by non-programmers so that end user can also use it without doing any coding. Sprint 3 review. So on child vocabulary acquisition, I have made Vocalab, the web research portal. Goal and scope. The goal in one sentence: a researcher never opens a terminal, design, run, and watch the report from the browser. In scope, the web console, the no-code builder, live inspector, data upload, the PDF report, and release 2. So all met. The pivot, the shift. Before a validated engine only I could drive, config files, Gradle, raw CSV, after the same engine from a web page. Build a study with clicks, watch it run, download a plain English report from a research tool into a usable tool. The builder's design, preset studies, then children, parents, and home with sample controls, and a live summary as you click. Let me show it running. Here is a live demo the builder. So Vocalab Live, I apply the attention study preset, then type an exact attentiveness of 0.72, a direct client request from my review on the product demonstration, where setting the value in decimal. Researcher wanted precise values, not just presets. Every parameter accepts typed input, and the tips panel explains each control as you go. Now the live demo, the run. Now the run. A small Flash server launches unmodified engine, resets the identical to the command line with a queue so jobs never collide with each other. So here is the live view on three Jacamo inspector are embedded in the page. So first is agent might, then organization, environment. So you are watching the children think, and the quick test finishes under a minute with the chart and table below. So self-contained engine. Under the hood browser, Flask, server, Jacamo engine. The engine is the unmodified Sprint 2 simulation. The portal only writes a config and runs it, so the portal numbers carry the same validation. So anyone can bring their own data. Researcher can upload their own corpus in format of CSV, raw transcript, or a zip from TalkBank Child's website. It's converted automatically into a new word pool and assigned to a parent profile. That also respect licensing. Everyone brings their own copy of the data. So here is the report, PDF report, the centerpiece for each child. The report finds weakest of 5 levers, scored on a normalized 0 to 1 scale, and writes a personalized plan. Here is a real one. Live demo of the report. The PDF came from the run you just watched. The short version upfront, each child's problem and solution in plain words. Then per child, the bottleneck, ranked steps for a caregiver, a goal, and what success looks like. After client feedback, I made it read like a problem solver, not a statistics printout. Challenges and solutions. 3 real challenges. A web page can't run a Java engine. Solve with the Flask job server, port forwarding, and a queue. The weakest lever bug, where every child showed the same bottleneck, solved by normalizing all levers onto one scale and direction check. And a fragile PDF writer hardened against unusual characters and long word list. So here's the outcome and release too. So that's delivered. The outcome Vocalab, no code builder, self-contained engine, live inspector, data upload, and the automatic report. So release 2 is delivered as well. Our study runs in minutes from a browser, no programming needed. So Sprint 1 made the engine trustworthy, and Sprint 2 validated it. And on Sprint 3 made it usable by anyone without doing any coding. Thank you.